Okay, I'm going to try to give you one last example here, and while we're at it, let's make it a little bit different. So this becomes a little bit of a reading question. If you read the question, we're trying to find the coordinates of C so that AB to BC, the ratio is 2 to 5. So notice we're not trying to find a point somewhere along A to B or along segment AB. We're trying to find a point C such that AB to BC has to be, so C is going to be way up here, a ratio of 2 to 5. This is actually the small part. So I don't know if I can kind of shrink this down and maybe try to draw in the rest of what this would be, because we're looking at a situation, whoops, where, let's grab a different color here, we've got maybe all the way up here for the ratio of, let me just do this part here, that might not even be big enough to get this to be 5 compared to this length here of 2. So something like that. So what am I going to do? I'm going to take it off the coordinate graph, same as I did for the other ones. So let's go ahead and redraw some triangles, and maybe I will just go ahead and make a triangle out of the green here and say that I've got this little guy, so to speak, and then my length here, continuing up in the same direction, and giving me those nice similar triangles we saw for the others. So this is A, this is B, and we're finding point C up there somewhere. So again, I'm going to go back to, we got to really think about what do we know and what do we not know. What are like my given lengths? So 2 and 5 are my ratio that I know. So I'll go ahead and put those on there. And then my countable lengths, remember we had some countable lengths. My countable lengths in this one, I don't know this distance all the way over or all the way up because I don't know where point C is. But I do know this and this. I know from A to B I went over 3, and from A to B I went up 6. So I do know for sure the lengths of my green part here are 3 and 6. And in this case, my unknowns are a little bit different. My unknowns are the red lengths. So if I want to put letters with those, I can go with D, and I'm going to use E this time for my unknowns. And that's how far do I have to go over and up to get to C. So from here, let's go ahead and set up our proportions. We've already talked about how these triangles are similar because I've got corresponding angles congruent, right angles, and of course the other angles are congruent. So by angle, the triangles are similar. I might have said congruent, I meant similar. And therefore, if the ratios of the corresponding sides need to be the same, so I want a ratio of 2 to 5, which means the ratio of this has to be 2 to 5 and the ratio of this. So I'm going to go ahead and set up a couple proportions here. Let's see, I like to start with an unknown length. So let's start with D. If I start with D, I would put 3 with D, and I would say I have a ratio of 3 over D equals 2 over 5. Quick cross multiplying gives me 2D equals 15. So D is 7.5. And then my other ratio, I could make a ratio with E, so 6 over E is going to be equal to 2 over 5, and that's going to give me 2E equals 30, or E equals 15. So from there, now I just need to actually solve the problem, and I need to talk about how I'm going to actually get my point. So I'm trying to get point C, and I know C is going to somehow come from D and E, but not necessarily be D and E. So again, I go back to my picture for this, and when I go back to my picture, I'm going to look at what D and E are, and D is this and E is some distance up. So D is over from point B, not from point A, but from point B. So I'm going to have to take the x-coordinate of B, before I wrote it this way, x-coordinate of B, and add D to it. So the x-coordinate of B is 5, plus D was 7.5. And then the y-coordinate of B also. And then I'm going up from there. So I'm at X, however far I am over to get to B, and then I'm adding D to it because D is that length. And then however far up I am to B, that's my Y value, and then I'm going up an additional amount that I called E. So my y-coordinate of B plus E. So y-coordinate of B was 7 plus 15. So I'm proposing that my answer would be 12.5 and 21. It'd be nice if our graph paper was big enough that we could check that out and see if that seemed reasonable. 7 plus 15 is not 21, that's 22. So let me do a quick math fix. And then we should be good to go. Okay, how's that look? So that's, of course, just one way to do it. If I was going to do it the other way, I told you that you're welcome to do it this way, and sometimes this makes a little more sense to me. I'm going to go ahead and draw it, but not redo the whole problem. In terms of the solving, I'll just set it up. I started with a length of 2, and then a length of 5, or comparatively, so pretend that's a straight line there. And instead of drawing the two separate triangles, I could go ahead and say, let's figure out how far total I need to go over, how far total I need to go up, and then we've got this intermediate line, so to speak, right in here. So again, my countable things were this 3 and this 6. That didn't change. Now my variables, I could do a couple things. I could call this D and this E. I could also call this entire thing D. That's really up to you. And those are your unknowns. Use your triangle proportionality theorem. Use similar triangles. Go ahead and solve. And then just be careful at the end, because when you're figuring out your answer, D is a distance from point B. Remember, this is point B here. But E would be a distance up from your X coordinate or your Y coordinate of point A. So just make sure you're adding or subtracting from the right thing. And again, that goes back to your graph and where things are located in relationship to each other. So you can try it that way. You already know what the answer should be. So if you're not getting the right thing, look at what you're adding, and you should be able to work it out.